Hey there, I'm an Untitled 8th grader from John F. Kennedy Middle School. And lately, I've been talking a little bit about calculus and kind of the simple starting things you need to know for calculus, such as limits, and I've even started a bit on derivatives. Today, I want to continue on with derivatives, and I want to give you guys a few more examples because I feel I haven't been giving enough examples for you guys to truly understand how to solve the problems. So today, I'm going to give a few complicated examples so you can kind of merge the chain and power rule, which we're going to be using today, together and solve problems. So why don't we get started by reviewing what the chain rule and power rule is. By definition, the chain rule says if f of x is equal to h of g of x, then f inverse of x is going to equal to h inverse of g of x times g inverse of x. Okay, so that's very simply said the chain rule. The power rule next. Let's say f of x is equal to x to the power of 5. F inverse of x is going to be 5x to the power of 4 because you're just going to take the exponent forward and then you're going to multiply that subtract that exponent by 1 and make that the new exponent. So, why don't we get started? Our first example here, we're going to simply use power rule, because we could take the derivative of each term simply and you would get the value of whatever it's going to be. So, let's say we have f inverse of x, this being shorthand notation when you write a little line between the f and the x. F inverse of x is going to be, so if I were to take this exponent forward and multiply it by the 3, again, when you're taking the exponent down, you're multiplying it by the previous coefficient, which is usually 1, but in this case it's 3. So 2 times 3 would be 6. X stays the same. If you subtract 1 from 2, you're going to get 1, so you really don't need to write that down. So it's going to be 6x plus, this is x to the power of 1, 1 times 5 is 5, x to the power of 0 is nothing, so it stays at a 5. Plus 9, the derivative of a constant is 0, as we will find out in number 5. But for now, this is our value for the derivative. Again, very simple here with the power rule. Nothing too crazy. Next example though, f of x is equal to x squared plus 5 to the power of 5. Now, some people who have not learned calculus yet might have taken x squared plus 5, x, and multiplied it by x squared times plus 5, x squared plus 5, x squared plus 5, x squared by 5 times, so they can keep multiplying in and get the right answer. But thanks to calculus, there is a shorter way of doing this. But it involves both the chain rule and power rule. The way you have to think about this one here is you're going to think about it as this being g of x and this one being h of x. This 5 is going to be kind of the outside function here. But let's start off with basics. What we're going to do here is it's going to be f inverse of x. Now the first thing anyone could think of doing here is using power rule because we have an exponent around this. So why don't we go ahead and do that? 5 times, and we're going to keep x squared plus 5 the same. Because over here it just says the derivative of h, so we're just kind of using power rule to kind of take the derivative of h in this case. And then we're going to find the derivative of g of x later. Of x squared plus 5 to the power of 4. You can't forget to subtract the 1. Next, what you're going to do here is you're going to multiply it by 2x, because the derivative of x squared is 2x, and then when you take the derivative of a constant, it is 0. So in this case, this would be the answer, so let me just write it again so it's much clearer, because I don't think that's too neat there, of 5x squared plus 5 to the power of 4 times 2x. And that is the derivative of x squared plus 5 all to the power of 5. Again, very simple. Now this is where we're going to continue doing that same type of thing. Again, think about this as the majority function, like the g of x. This 2 here as a as the h of x, and now we're going to simply do it. And think about this as the coefficient of all of this. So basically, to do this, again, we're going to multiply this out here, making this going to be 12, because remember, you're multiplying this by the coefficient. 12 times x cubed plus 2x plus 4. If you subtract 1 from here, it's going to be 1, so you don't even need to write it down. And then you're going to multiply it by 3x squared plus 2. And that is what the derivative is. And in this case, it is very simple to simplify this part, so why don't I clean that up a little bit here. F of x is equal to 12x cubed plus 12x cubed plus 24x plus 48 times 3x squared plus 2. And that is the derivative of number 3. Okay, so again, this is kind of simple, kind of in our range. These ones are kind of a little trickier, which you have to think a little bit about. But again, most of our simple problems here are going to be these, but I just had to bring this in so you guys could learn how to kind of mix chain rule and power rule together. Next question here, number 4. We have x squared plus 3x plus 4 to the power of 30. Now, as I said here, you could multiply all of this. Like here, you could have multiplied x squared plus 2x plus 4 times x cubed plus 2x plus 4 again, but that's a very long process, especially when you have an exponent of 30, which you really don't want to do. And again, calculus has made our life easier. You're simply going to do f inverse of f, the derivative of f of x is equal to, start off with the power rule. It's going to be x squared plus 3x plus 4 to the power of 29, because you subtract 1 each time. And then if you're going to multiply it by the derivative of that, it's going to be 2x plus 3, because the derivative of a constant is 0. And that is simply said what the derivative of this is going to be equal to. And why don't we change the color a little bit here so it's much bolder. F inverse of x, and I need more space. So 30 times x squared plus 3x plus 4 times 29 times 2x plus 3. That is the derivative of that. Okay? Last one. I had a whole video on finding the derivative of a constant. Now the way you gotta think about this over here is f of x is equal to 100, okay? Now we are trying to find the derivative of it. And as I have explained, if this is, let's say, 100, f of x is going to look like that. The point of taking a derivative is to find the slope of a tangent at any point on the graph. Let's say if I were to take a tangent here. Okay, let me get another marker so I can explain to you. If I were to take a tangent here for the graph, it would look like that. If I were to take a tangent here for the graph, it would look like that. Oh, wrong marker. It would look something like that. So basically, if you were to take the slope of a constant, again, very simple, it is going to be a 0. And so, therefore, if you were to take the slope of a tangent line of a constant function, that is also going to be 0. So that is basically why the derivative of a constant is 0. Just again, for those people who haven't watched my other video, but the other video goes much more in depth about why it's actually equal to 0. But that's simply said why it's equal to 0. So here we can have our answer equal to 0. So I hope these examples really did help you. I think they personally helped. They helped me understand it clearer for sure, because the videos that I created before were to get the concepts in your mind. This one's to help you guys think about how to use those concepts in actual problems. I really did think this was a good thing to do. Please like and subscribe to the video. Give feedback on my videos, please. I'm always looking forward to it. And thank you for watching.